In this video, we will continue our learning about trigonometric identities. And as I mentioned earlier, identities are something where left hand side and right hand side are identical in value. So this is used, all the trigonometric identities are used for solving questions where we have to prove that right hand side and left hand side are equal. So before I start on the identities, further identities, I want to tell you one thing, that a square, sine a square is written as sine square a. Similarly, cos a square is written as cos square a. And because we are talking of a right angle triangle PQR with Q at 90 degree, then the relationship among the different side is given by Pythagoras theorem. Hypotenuse is equal to side square plus base square. Now this is the basic relationship of a right angle triangle, that the hypotenuse square is equal to side square plus base square. Now we divide both sides by h square. So this will become h square and this will also become h square, like this. And as you know, any identity we can divide by the same value both the sides, or multiply both the sides by the same value, or add same value to both the sides and subtract same value to both the sides, then the identity remains unchanged. So in this case, what we have done is divide both sides by hypotenuse square. So now this will become 1 equal to side square over h square plus b square over h square. Now this is side over h, this we can write as s over h whole square plus b over h whole square. Now side plus h is what? What ratio is side plus h? Side plus h, this over this is sine. So this becomes sine a square, and the other one becomes cos a square, or in short we can write it sine square a plus cos square a. So you can see that 1 is equal to this much. Now if you have to find sine in terms of cos, then we can also write this. So this is the identity number 9. So we have learnt up to 8 identities earlier, and then the another form of this will be sine square a is equal to 1 minus cos square a, and cos square a is equal to 1 minus sine square a. And if you have to write sine a, then we can write sine a is equal to under root of 1 minus cos square a, and cos a is equal to under root of 1 minus sine square. So this was the basic relationship, and then from this we can prove this identity, that 1 is equal to sine square a plus cos square. Now if we divide both sides of our earlier identity, divide by s square. So we had h square is equal to s square plus b square. So what are we doing? We are dividing by s square. So this will become h over s square, and this is s square over s square, plus this will be b over s square. So this would mean h square over s square, h over s. So this is cosec square a is equal to 1 plus cot square. So b over s. B over s is cot square. So this is identity number 10. And then if we divide both sides, divide both side by b square, then we will get h over b square equal to s over b square plus b square over b square. Now h over b, h over b, h over b is sec square, and s over b, s over b is 10 square plus 1. So this is the identity number 11. So this is number 11. So we learned, what we have learned? We have learned 3 more identities in this case. Number 9 is equal to sin square a plus cos square a is equal to 1. So this is one identity we have learned. The second one is cosec square a is equal to 1 plus cot square a, and number 11 is sec square a is equal to 10 square a plus 1. And how we have got all these identities? By applying Pythagoras theorem, which says the hypotenuse square is equal to side square plus b square, and that relationship we have divided first by h square on both sides, and we got this as the first identity. Then we have divided by s square on both sides, then we got identity number 10, and then finally we divided by b square, then we got the identity number 11. Thank you.